Welcome, welcome. Today we are doing 5-4 medians and centroids. If you remember, the very first page in the Unit 5 was a definition sheet, so we've already kind of defined all of these words. Today we're going to talk specifically about medians, the point of concurrency where they're a median. A median is a segment that joins the vertex of a triangle to the middle or the midpoint of the other side. Okay, so it goes from the vertex to the middle, cutting that side in half. Now, if all three medians, so if we draw a median from every side of a triangle, we are going to create a point called the centroid. So the centroid right here is P, where all the medians intersect. Okay, list the medians here. So the medians would be AE. The next median here would be BF. And the last median would be CD. Now the centroid is where they all intersect. The centroid is point P. And then what special properties exist? Well, I know that, let's say that BF had a value of 30. Okay, what's going to happen is it is going to be split up in sections. So if this was B, P, and F, I'm going to cut it into thirds. I would have 1/3 down here and 2/3 up here. So if the whole thing was 30, 30 divided by 3 would tell me that PF down here would be 10, and then 2 of those up here would be 20, so BP would be 20. So that's kind of the breakdown of what's going to happen every time. So let's just pretend that AE, same thing's going to happen. Let's say that AE, the whole length of AE was 15. Well, if the whole length of AE was 15, I could divide that in 3, and I could say that PE would have to be 5. And then 2 of those 5s up here would make AP 10. And that's going to be the breakdown every time. That's kind of the special features of a median, is it's 2/3 of the way. Centroid is also known as the center of gravity. I don't know that they talk about that here. The center of gravity, which is kind of an interesting piece. All right, so down here, we want to break down all these things. Can we figure out anything? No. I usually look at what I know, and then I write everything I know, then I come and answer my questions. So if I know JK, this whole length is 22. Well, if the whole thing is 22, I'm going to cut it in half for 11 and 11, because that's the middle. So if KN right here is 13, well, I know that this is the middle of this side, so this whole thing is 13. OL, this side right here, is 18, which is going to make the whole, this over here also 18. So I don't know anything in the middle here. So I don't know if they're going to ask me any of those questions, but we'll see. KM, that length is 11. And L, this length is 13. KL, the whole length here, add those together for 26. JO was 18, and JL, the whole length, is going to be 36. That's kind of like how I would do that problem. I believe 2 is going to be similar, so I'm going to go down here to number 3. I'll give you the answers to number 2 in a minute, so if you want to do those, I'll go ahead and give those answers in just a minute. Here, G is a centroid. Triangle ACE right here. Oh, AC. G is the centroid of AC. Good. AG, this length right here is going to be 8. GF, this length right here is going to be 7. And BG, this length right here is going to be 5. So you have to kind of ask yourself, do you have the smaller side or the longer side? Because you have the middle, the end pieces here. Now, this is the longer side. So that means there's 2 over here. So 8 divided by 2 is 4, which means this one over here would be 4. Now this 5b, that's the shorter side. The longer side goes to the vertice. So that's 1/3 is 5, which means I'm going to have to double it over here to make this over here would be 10. Now here's C to F. GF is the shorter piece. This piece is to the vertice, so this is the 2/3 part. So 1/3 is 7. Double it up here to get 14. Now I did everything I know. Now I can probably come over here and answer those questions. GD is 4. AD is this whole length, so 8 plus 4 is going to give me 12. CG is 14. GE, I got 10. And then BE, the whole length, 10 and 5 is going to give me 15. So again, these are really, really similar. Go ahead and write everything out here, fill in those numbers. I'm going to put the numbers in now, so pause before I start it. Okay, this one ends up being 56, 30, 50, 90, and 84. Go ahead and do a double check with that. TX down here is going to be 18, 19, oh no, 18 and 9, 12, 6, and 14. Okay, we're going to go on to the next page. I really only did 6 and 7 on this next page, so we're not going to do the whole thing. 6 and 7 are what I'm going to work out. So if you want to pause and try those, go ahead and do that. V is the centroid of the PQR triangle. SR, the whole length is 21. So what I'm going to do first, since I know that whole length is 21, I'm going to divide it by 3. My shorter piece is going to be 7. 2 of those would be 14. 7 plus 14 is 21, so that's going to take care of that. VU, this shorter leg down here is 8, which means this piece will be doubled out, it'll be 16. And then PT, the whole thing is 15, which means divide by 3, I'm going to get 5, times 2 will be 10. So SV is going to be my 7, VR is going to be 14, QV is going to be 16, QU, 16 and 8 will be 24, PV right here will be 10, and VT right here will be 5. Okay, so that's kind of how we work those out. So you have to remember the rule, divide by 3 or multiply by 2. What do you have? I like to also draw out to the side, so I remember 2/3 and 1/3 if I need to draw that out to the side and work it out. Okay, G is the centroid ABC. BF, the whole length is 72, so if I divide that by 3, I get 24. 24 times 2 is 48. Add those together, I get 72. 64 AC is 64, which means I'm just going to divide that by 2. I'm going to get 32 here and 32 here. GE is here, it's the shorter piece, is 27. So multiply that by 2, and I'm going to get 54 over here. Those are the things I know. I don't have any right triangles, I can't use Pythagorean theorem, I can't really find any other values there. So let's see if I found everything I need. AF is 32. FC is also 32. BG, I already got, is 48. So that's why it's really helpful is when I have the information, I write down everything I know first, and then I see if I answered my questions. GF is here, 24. AG is here, 54. AE is the whole length, 54 and 27, and I get 81. There we go. Okay, so that's what I was going to do, just those 2 problems. I am also going to continue on. 5-4 continues, it's a few pages. We're going to do altitudes and orthocenters as well. So altitude is, again, when it comes from the vertex. So the only one that doesn't come from the vertex is going to be your perpendicular bisectors. Everything else comes from the vertex. To the opposite side so that it is perpendicular. This is also known as a height. So it's nice to know, like, it's the height of a triangle or a building or whatever it is. What is interesting here is the altitudes can be inside, outside, or on the triangle. So if it is inside, you can bring that height straight down like this. There we go. That would be your altitude or your height of that triangle. Now this triangle is obtuse, which means you kind of want to extend. I like it to be straight, so I'm going to use a ruler. You can extend this line a little bit. And now, if I draw my height from the vertex here, it comes straight down here. Notice that this altitude is outside of the triangle when it is obtuse. It will be inside when it's acute. And now, when it is, notice that the height here is going to be right here. Right? So it's a side of the triangle here when it's a right triangle. Okay, so that's kind of what happens with the heights of these shapes. When you do the altitudes of different triangles. The three altitudes intersect to create a point of concurrency called the orthocenter. Now when I use this diagram, list the altitudes. The altitudes would be AE, BF, and CD. Now the orthocenter here is P, and this one doesn't really have any special features. So all the other ones kind of have a special feature about cutting in half, being 2/3 away, something like that. But this one, there's not really any special features. So, center review. Read through this if you remember. I use a mnemonic device called PAMA-SECO. Okay, so I use a mnemonic device called PAMA-SECO. I will do it on this paper clip. You should probably have a separate sheet of paper somewhere, or a note card or something. These are going to be the lines. These are going to be the points of concurrency. So the lines that I drew were perpendicular bisector. I had an angle bisector. Today we talked about medians. And then this last one was an altitude. So that's my PAMA. Now my SECO is the point of concurrency. So C here is circumcenter. I stands for an in-center. The second C for median is going to be my centroid. And my last one is my orthocenter. Okay, so again, before you answer those questions, can you put this away? Can you remember PAMA, SECO, and could you answer those on your own? The three something on the sides of the triangle intersect at the circumcenter. So this one's going to be my perpendicular bisectors. Can you fill these in without looking at that little sticky note we just created, or without looking back at your notes? The three blank of the angles of a triangle are at the in-center. Angles. It's going to be my angle bisectors. The three blank intersect at the centroid, the three medians. The three altitudes intersect at the orthocenter, and a blank is equal distance from the vertice. Equal distance from the vertice is my circumcenter. So that is the perpendicular bisectors, the circumcenter. A blank is equal distance from the sides of the triangle. That is my angle bisectors, or my incenter. So remember, this one we would draw a little triangle. Equal distance to the vertices makes that circle around the outside. Now this, if we had a triangle, and we were equal distance to the sides, we would have a circle inside. It's an incenter. Okay, and the radii are the equal distance. So the equal distance are considered your radii. To the side or to the vertice. That's what happens in those two. That's a little bit tricky. And again, one good thing about this is information that does not really carry on through a lot of geometry. But it is good to remember, and it is good to remember this mnemonic device, PAMA-SECO, that would help you. So have that written down somewhere. I'm going to go to the next page here. Still on 5-4. This one's a long set of notes, 16 minutes right now. Okay, can you look at these and identify what's happening? What is the line? Directions based on the markings, classify each center. So I'm going to decide which line is it, P-A-M-A. Which line is happening first? Once I decide what line it is, then I would know what point of concurrency it is. So I've got to figure out what line is happening first. Go ahead and go through this. So my line here, these are angle bisectors. Okay, these ones came from the vertice to the middle. Vertice to the middle, these ones are going to be medians. Now this one, from the point of concurrency, all to the vertice is equal distance. So if they're equal distance to the vertice, those were my perpendicular bisectors. Now these ones are equal distance to the sides, not the vertices. Those are my angle bisectors. This one cuts, I believe that's cutting the angles in half, right? So these would be angle bisectors. And once I know what the line is, then I can figure out what the point of concurrency is. So hopefully you can fill those out. Go ahead and do this side real quick. I'm going to come back and do it in just a minute. This one would have been perpendicular angle bisectors in center. Medians are centroids. Perpendicular bisectors are circumcenter. Angle bisectors are incenter. Angle bisectors, oh, sorry. Oh, are those both incenters there? Those are both the incenters, depending on what we need from that. Interesting. Okay, on the next page over here, now these ones are altitudes. Those were heights, these are altitudes. These ones are cutting the side in half, and they're perpendicular. That makes it a perpendicular bisector. These ones went from the vertice to the middle. These are medians. From the vertice perpendicular, these are altitudes. These ones, notice that these are not one line. This goes to the center, cuts these sides in half, they're perpendicular. These are perpendicular bisectors. You've got to be really, really specific when you're looking at the drawings to see what kind of line it is. So again, an altitude was an orthocenter. Perpendicular bisector is a circumcenter. Medians are centroids. That word got a little bit ugly, sorry. Altitudes are orthocenters. And then perpendicular bisectors down here are circumcenters. So hopefully that was kind of good review. I'm not exactly sure what the homework is going to be. You probably know by now because it'll be on your weekly thing. It'll either be Alex or this will be a Canvas assignment through your notebook. Good luck. Have a fabulous day. See you in class. Get caught up and take advantage of these 4-day weeks in this no school November. And I will see you next time. Bye.